All right. Good morning, everyone. Welcome back from the break. I hope you had a good and refreshing break after the stunning keynotes. And I'm Prashant Agrawal, Principal OpenSearch Specialist Solution Architect, focusing on the OpenSearch. And today I'm going to talk about how you can build an AI-powered search where search does not really just find the things what you're looking for, but it also understands you. So here I'm going to cover a couple of things as part of my agenda. So where I'm starting with what are the challenges we see with the traditional keyword search. And then we talk about how search has evolved over a period of time. So I'm going to talk about how it has been changed from in 2000s to 2010 and 2020s kind of a scenarios. Then I'm going to talk about what are the building blocks you need to build an AI-powered search. Then I will be having a live demo where I would be showing you a different kind of searches using the keyword search, semantic search, and the hybrid search. And then we'll talk about some of the best practice, what you need to consider when you're building such kind of sophisticated search solution for the production scenarios. So before I go further, I just want to see in the room how many of you are using OpenSearch for the search? So raise your hands if you're using already for the search. Probably no one? Okay. Then that's a good topic. Then you will understand on what kind of scenarios you can use the OpenSearch for the search. And the reason why I'm talking about search is we have seen a lot of customers getting frustrated with their users when their users are typing something and they're not able to find the relevant documents. So this is something we all experience, some sort of bad search results, what we get. So here if I type red swoosh under 20,000 won, then you get some sort of things which is matching with the word red. So you see some of the documents coming as the bag or hardship, or you also get some sort of swoosh. But it's not really understanding what you're planning to search, because swoosh can have a different meanings, and it is just kind of matching the words, but not trying to match the meaning out of it. The second example, what I have is let's say if you are going for a work and you wanted to find the comfortable swoosh for the work. When you are searching for those things, then in some way your catalog might have a different meaning of the word as swoosh, or you might have mistyped the word as the swoosh, or it could be your catalog calls it as a sandals or boots. So in that way, you might also be getting some irrelevant documents when you're only searching for those keywords for using the OpenSearch or any other search solutions. And also it can also give you some of the out of the league items like the socks in this picture, because it's kind of matching the word as comfortable or work, and your socks could be in the catalog which is having these two words as well. So here the thing is we have seen how those searches are not returning what you are looking for, and the user really struggles with the synonyms, typos, and it fails to understand the intent what a user is trying to search for. So this is where we have seen how technology has evolved in the search space. And if we look at how search has transformed over the years, so you started with the web in the 1980s or 1990s, then we got the mobile phones where we kind of do some sort of searches. Then we have the multimodal, where you're not only searching for the text keywords, but rather you're also searching for different modality, for example, images, videos, audios, etc. And then we have the era of the generative AI, which is kind of shaping the overall experience how users are coming for the shopping. It's not only giving you the data, but it also gives you some sort of recommendation based on your past experience. So this is the way this is kind of the evolution of technology, which has been also critical and evolved differently. And now if I look at the evolution of search in the context of the OpenSearch, so that also has three key steps. So one is the foundation piece. So foundation piece starts with the lexical search or a keyword-based searches, which uses the term frequency or inverse document frequency as the scoring mechanism, or also uses the BM25. So these technologies basically convert your input tokens using the different analyzers or tokenizers to kind of make somewhat better, which works to some extent, but not all the scenarios. So it was kind of fast, efficient, and great for the exact matches, but it only understands the text, but not the user intent. And to solve the issue of synonyms and dictionary, we got the sparse search. So this is kind of converting your search terms into an array of different tokens which are similar in meaning, but they are still the text matches. So it can be good instead of just running the normal search, but it cannot be better for like if you want to search in a different language, like you want to search in English or Korean or any other language, then the sparse search might not work well. So in that scenario, the breakthrough came into, which is kind of the vector search. This is where you convert your input into the multidimensional vector data, which is called the embedding. So basically converting your text data into a floating array, which has some numbers, and then spreading into three-dimensional vector space. So here we are kind of converting your text data into the embedding using the different models. And this could be similar to like what I have in my previous example, like if a user is searching for the shoes, and your catalog might be having the sandals or like boots, etc. When those things are plotted in the graph, then they are kind of together so that when a search comes in for the shoes, you also get it for the boots. Then the fourth one is the hybrid search. So keyword search works for the exact matches. It works perfectly if you have a really specific requirement. For example, if you want to match any car part number or any specific kind of product with the ID, then keyword search will be good. And the semantic search or the vector search could be good if you want to find the intent. So then comes like how we can combine both of these words and get best of both worlds, where you have some part of it written into the keyword search for the exact matches, and then use the semantic search as part of the vector embedding. So that's where the hybrid search kind of blends both of these words and ensure that we capture not only what the user sees, but also what they mean. And then lastly, we have the multi-model search. So as I was talking about the revolution earlier, where we are not just limited to the text data. We have a lot of images being captured, videos being recorded. Or for example, I'm speaking here, right? And that's also being recorded. It could be converted into the text as the transcript. And instead of looking through all the videos or the presentation, you can just search through a specific keyword out of those. So that's where the multi-model search comes into the picture. Then second piece comes as part of the advanced search. So on the left-hand side, we have the document processing with the ML inference processor, and on the right-hand side, it is the search querying with the ML inference processor. So with the left is like you send the documents, your document gets converted into the embedding and stored into the OpenSearch, and then on the right-hand side, once you get the data from the search query or like the lexical search or the semantic search, those data could be reprocessed using the ML inference processor for the re-ranking and other things. Then the second one is the user insight behavior. This is the one of the plugin within the OpenSearch where you can track the behavior of the users and then give them recommendation based on their past experience. So for example, like a user, if you have searched something today and you come back after 10 days, it might maintain those kind of history and give you the recommendation or start from like where you left 10 days back. And then third one is the LTR and the re-rank processor. So this is like you get some sort of data and then you want to pass it on to your own model for doing the re-ranking, so that what users are going to get is based on the re-rank models, which is kind of capturing the user preferences and the user behavior data. Then the last piece in this particular evolution is the AI-powered search with the LLM and agents. So here we have like 5 different components. So one is the query understanding. So when we say about the query understanding is like when you send any text keyword to the search system, and if you try to generate the embedding out of it. So generally the LLM models which generates the embedding, it works well with long sentences or the long piece of text, and it might not work well with the smaller text like black shoes or red shoes. So that way, with the query understanding phase, we try to use the LLM to kind of create a little bit longer description of that search keyword, which can get passed to your OpenSearch. Then the query rewrite is something like finding the metadata from the user's question. So here, one of the important pieces is the user persona, like who is searching. For example, black shoes, if I'm searching, then I might have a different result versus what you are searching for the black shoes, or what my wife would be searching for the black shoes. So we all have like a different kind of personas or the taste which we want the search results to return. Then the query classification, so this could be something like if a query is coming from the male or female, it could be a gender affinity, or it could be a geographical region, like whether it's coming from US, Korea, APJ, etc. So that kind of a thing could be classified as the query classification. Then final is the LLM as a judge and result summarization. So here you can use the LLM model to vet the query, what you get out of those LLM models, and then it can also give you the summarization based on the user input. So here we talk about like how the search has evolved. So let's see like why intent matters. So here I'm going to talk about the intent or the context in three ways. One is the user context, second is the domain context, and third is the business context. So when we talk about the user, so it could be like I'm an active traveler looking to explore cities and would like to order food which is local to that particular location. So that is my interest. So that is the user context. Whenever I'm going to any food delivery app, I'm searching for a food, it will give me the recommendation based on my taste and flavors. And here we have like a different interest, like you could be related to the sports, fashion, food, childcare. It also has the historical purchase information, and then it will change you the query behavior based on the user. And the fourth one could be based on like the price, like what kind of price I'm looking when I'm going for the searches. Then second one is the domain context. So domain context could be like if I have a new product launch within my company, then I want to promote that particular product over the other product. So that's where the domain context is important and required. And it could also vary industry to industry, like some certain keyword on the manufacturing industry might have a different meaning versus like into the travel and hospitality industry. So an example could be like, if I'm searching for an apple, then apple could have a different meaning. And whether I want to go for the grocery store to buy an apple as a fruit, or if I want to buy an iPhone, I want to go to the Apple store. So that's where the domain and the industry is relevant and important when you're doing the search. And last one is the business context. So this is where you want to kind of promote one of your product over the other product as well, so that user always get the latest product. It could be relevant in the news industry, where the latest news is always important than the older ones. So you might want to promote those kind of searches on the top. So I also have a demo, but in this demo, I'm going to kind of focus on to the user context. And when I say about the user context, is like when I enter the black shoes. So I have three different personas, which I'm going to talk in my next slides, and how the results would vary when each of them is searching with the same keywords. So before I get into the demo, let's see like how does the search query get converted. So there are two pieces. One is the pre-processing of the query, and second one is the post-processing. So when we talk about the pre-processing, it's like you get a query from the user, and you can just use the OpenSearch to run the query. This is kind of the traditional way of searching, how we all have been doing it. But the other way is like query routing. So when I say about the query writing, is it could be based on the user personas, which I was talking about, and those user persona could be sitting onto your OpenSearch index, or it could be sitting into any external databases. So here we have the UBI data, and also have the user context, which can be married to the business or business priorities as well, based on what goal you want to achieve with those searches. Then you can send those queries to the OpenSearch. The third piece is the anonymous path. So there you might not have anything specific to the user. It could be like new user coming to your website looking for some searches. So this is where you just have to have the domain and the business context when you are kind of reconstructing the query from the input keywords. And those kind of data could also be based on the market trends or the business priorities what you have, which could be stored into any sort of external databases or like OpenSearch itself. So considering these things, the benefits what we get is like we get the tailor-made search experience for the new personas as well as the primary personas. So they always get the recommendations what they are looking for. Then it also enhances the search experience, which kind of targets different kind of users coming to your website for the search. So let's see how does the search query works with respect to the routing. So I have a user here who is kind of 32-year-old female Hayun who values the quality and efficiency, interest in technology, fitness and travel, and she basically shops online pretty frequently. So she enters the user input as the black shoes, for example, and what happens is these input query gets passed into the LLM. So if you remember one of my previous slide where I was talking about you can use the LLM as a judge. So LLM is going to gather the context and the context for the user, like she is into the athletics or fitness shoes, she is kind of travel-friendly walking shoes is what she's looking for. And then also some sort of filter, like it could be the category as footwear and the gender affinity as female. So that LLM would be converting that single query, which is the black shoes, into the OpenSearch query, and the JSON on the right-hand side shows like the filter, which is the category and the gender affinity, along with the elaborated context and the data, what has been converted from the black shoes to a large description like women's comfortable, versatile athletic sneaker, dress like travels, etc., etc. So this is how your query phase comes in, where the query gets converted or elaborated, which gets passed on to your embedding models. And now when we are generating the embedding, then the embedding would be much better generating from those long text versus generating it from the black shoes. So let's see how does this work with respect to the overall architecture. So you can think of this as a high-level architecture, which could be like how you can create and run the query within your OpenSearch. So you have the user query, and as I was talking about the persona, based on the persona, it gets passed into the agent. So here I'm using the Strands Agent. So basically, Strands is kind of Python framework which would be used for orchestrating the API calls to the LLMs and the tools. And these agents have three things. One is the prompt, what you're going to send. Second is the LLM or the SLM models, which they're going to use for generating the embedding. And third one is the different kind of tools. So here we might have the tools like OpenSearch tools or the query tools within the agent framework. Once those query comes into the Strands Agent, then it sends those prompt to the LLM, get the expanded query. And the next thing is we want to create some sort of filters or the definition out of that query. So which I was generating with respect to like adding the filter for category or the price or the gender. Once you have those query with the filters, then you send those queries to the OpenSearch tools, then it runs the query, gets you the personalized results or the personalized set of data. So the thing is, once those personalized search results are returned, then how do you measure like whether those search are correct, whether it's meeting the latency or the performance what you're looking for? So that's where the output really matters, and you have to consider about the different scenarios of, say, timeout. Can you really use this kind of pipeline to run the simple search queries? Whether your users would be willing to wait for that much of time. Let's say if query takes 5 seconds, but in most of the search applications, the response time is kind of in milliseconds. It could be like 100 millisecond or 200 millisecond is the SLA what you might be looking. So for that kind of a scenario, you should always also have the default path. So what happens is like you run the query to the OpenSearch directly. And let's say that query runs in, takes 100 milliseconds. And then you have a timeout set up for your complex process of like converting those query using the LLM to be, say, 500 millisecond again. And if you did not get the response back with that formula or kind of the architecture, then you kind of return the response to the user so that users are not really abandoning your search websites. Because generally, if a user comes in, they're really stuck there for a couple of seconds. And if they cannot find what they're looking for, they will just kind of do the window hopping, go to the different portals or the different sites. So that's where you might lose the user context and the user interest. So you have to make sure like you are kind of keeping the user engaged by returning to what they are looking for. And this is how like the architecture looks like, which I have a demo as well. So one thing which I just want to call out over here is like whenever you're building for the search solution, make sure like the timeout or the output parameters are well configured so that your users are not abandoning your system. So let's look through the demo which I have. So for the demo again, I'm going to have three personas here. So one is the Hayun, who is the marketing manager. She has interest on the technology, fitness, and travel, and her preference is like where she values the quality and efficiency, and she kind of shops online frequently. Then second person I have is Sojun, who is the computer science student. He's more onto the gaming or the programming. And as you know, like if he's a student, he's kind of budget conscious. He wants to get the cost-effective product first before the higher-end product. Then the third one is I have the Minho, who is the home renovation contractor who kind of likes the DIY project, gardening, sports, etc. And the preference what he has is the durability and value, and he's kind of the person who prefers the in-store shopping, so he might want to go to the store. And within the store, you might also have some sort of search solution to find what he's looking for. So let me jump into the demo. All right, so I have created an application over here, and this is based on the Strands Agent along with the LLM, and I'm using the Claude model for my LLM. So here I have 5 different persona. So the first persona is like none, which means there is no persona, no user context is available, no history is available. And if I run the search with the none as the persona, see if I run for the black shoes, the response what I'm going to get. So the steps of that execution is the query expansion, but the thing is we don't have any context about the persona, so there is no expanded query for this particular user. So black shoes remains the black shoes, and if you look at the OpenSearch query body, it is just searching for that particular word and getting you the response. Then if you look at the search responses, it gives you some sort of shoes, but it's not having a high score like the 79% relevance or 78% relevance. So this is kind of the problem when you're not having any sort of persona. Now let me switch back from like no persona to the anonymous user. So let's see what anonymous user is all about. So an anonymous user is often age 30, and his interest is on general shopping and kind of without personalization. Now if I run the same search query with this kind of persona, then my query is going to be expand as a general user, and it might have something related to like the general shopping and what kind of shopping might be preferred by the general users. It kind of expands my query into a little bit longer sentence, say like black shoes, casual dress, formal, sneaker, boots. Basically, you can think of like it's creating an array of similar keywords, a kind of synonymous keyword. And then that query goes into my OpenSearch query. So instead of black shoes, now I'm searching for these things. So user is not knowing like what's going behind the scene, but you are kind of trying to give them the recommendation what might be good for them. So this is how the second scenario would work. And here my confidence score is a little bit better from like 79% to 81%. Now let me switch back to my real or kind of a simulated persona, Hayun, who is kind of, as I mentioned, she is 32-year-old and looking for the technology, fitness, travel. So here what I'm expecting is once this query goes into the query understanding and the query expansion phase, then her interest should be captured. And when we generate that sentence, it should be capturing those words into that particular sentence so that when the embedding is generated, it has more contextual meaning than these two words. Let me run the same search again. So here, like it's taking a few seconds. So that's where I was talking about the fallback strategy. Like if your LLM models are taking more time, it's breaching your SLA or SLO, then you might want to get into the fallback strategy. So now if you look at the query, so here the query has been converted into the longer text, but it has also added a couple of filters, which is like the category and the gender affinity based on the user. So as my system knows like this user is a female, so then he's adding the filter for like the gender and also classifying that particular query as the footwear category. And if you look at the OpenSearch query, this is the query which is going now into the OpenSearch, which is automatically adding the filter. So there are two benefits to it. One is like if you add the filter, then your search latency gets better because filter gets cached into the OpenSearch. And the second thing is you get better matches with these kind of queries along with the filters. And here are like some of the source document which you can think. So we saw like how you can search across those text keywords and that gets converted into the different words. But so why can't we just use the sparse search here? So that in demonstration, what I'm going to have is like, I'm going to have the same search into, let's say, the Korean language. And if I search for these words, then it's also trying to understand the different language what I'm searching for. So you don't really have to build your search system considering one language. You can just use the LLM to convert your language into the natural language or the English language, and then get the query expanded onto the English language or any other language, which could be based on to the models what you're going to use. So now I'm searching for the black suit here, which is kind of in Korean, and I'm getting the similar or the exact same results where I'm getting the filters added, getting my query expanded and converted into the OpenSearch query. So this is kind of an interesting thing with respect to the retail search or the personalized search. So if you're looking to build any sort of solutions where search is critical, you can think of this techniques or the technology which you can integrate into your product. And the last thing which I have is the caching. So you remember I searched for the black suit. Let me search the black suit again for the same user who is Hyun. And if I search the black suit again, it should be kind of using the cache to kind of get me back the data. But I think I had a search for the Korean language, so that's why it's not cached. Okay, so if I run the same search again, then I'm getting the AI responses from the cache data sets itself. So that's what the feature what we have in the OpenSearch, which is called the semantic caching. So it kind of stores your expanded query and get you the relevant documents, so that if a same user comes in and it searches the same keywords, then it does not really have to go to the LLM to generate the context again. So that way you can save some sort of cycle in terms of the LLM calling an LLM API, etc. So that's what I have as part of the demo. And now if I go back to my slides. So this was kind of a high-level blueprint architecture for building any sort of search solutions. So next I have like, what are the things which you should be thinking when you are making it for production-ready system? So I have some tips and tricks to consider for the same. So a couple of things are like, I already talked about that, like the fallback strategy, like if your SLA is breaching, fall back to your standard approaches. Then you might want to optimize the LLM latency. If your large language model is taking more time, then you might want to use the small language models and then kind of use the lower dimensions, and all those things are good techniques for reducing the latency. Then you need to optimize your searches. So you can use some of the out-of-the-box features in OpenSearch, or you use any sort of other plugins. And OpenSearch itself has some techniques like quantization, memory optimization, filters, etc. Then whatever you're sending to the LLM model, you need to kind of log everything so that you get the better observability of like what your users are searching. And you can also enhance your search system in the backend as well based on the response what you're returning to the users. Then a couple of things is important with respect to the updates, because whenever you do an update into the OpenSearch, it's kind of a re-indexing because it deletes the document and then index that document again. So if you're updating if you're doing the frequent updates, then that might have a different impact on the latency and the performance. And the last one is, if you want to test at scale, you can use the OpenSearch benchmark to kind of process hundreds of millions of vector data, or like even billion scale vector, and run the test with your own data sets. So with that, I think I'm mostly wrapping up, and here some of the resources. So I'm also excited to say, like, I have recently co-written one of the first OpenSearch book, which is the definitive guide to OpenSearch, along with some of the other co-authors in AWS. So this book talks about like how you can get started with OpenSearch from beginning to the advanced level. And this book basically we launched into the OpenSearch Con North America this year. And apart from this, a couple of other resources are like the OpenSearch AI demos, which is available in the Hugging Face. I have some workshop where you can build an AI-powered search in just 3 steps, and some of the read-ups about the Strands Agent, which I have used in this particular demo. With that, I would say thanks everyone for coming here and listening to this session. If you have any questions, I would be around and would be happy to answer any questions you might have. Thank you.